Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to my WaterJet series. Not as much update in this video. I wasn't able to talk to these guys to either find some suppliers for the stainless or the guys for the hosing. So I was so busy at work and had some stuff I had to make in the machine shop this morning and go to a friend's house after work, so it just. And then for my car, I got some stuff this weekend that I got some issues with some stuff that I have to get going because otherwise this weekend will be very unproductive, just like last weekend because I have an issue with something and it's holding me up on my project, on finishing and completing a project. So. In this video, basically, we're going to be just finishing making the model like it is here. Which I guess I could have just asked him for the model. Anyways, so yeah, we're just going to go ahead and finish the model. And that'll probably take the rest of the video here. And then we'll start the weekend of the digital stuff and... again, I'm going to try my best to get that, the Zombie Alamo working. So, if you guys are into digital design, as far as game design, then yeah, or software design, then that might also be something you want to check out. Okay, so we had all that stuff done. Now... Now, basically, we need these parts here. So, aluminum 3 is 2040. Okay, so this is the 660, and this is the X, and this is the Y. So let's delete one of these. So this is supposed to be 2040. And this is going to be rename the bottom x-axis. The bottom x-axis is 660 millimeters. 660 millimeters. And as far as this looks, it looks like it butts up. Yeah, it looks like it just butts up to it. I'll show you guys here. So, bottom x-axis, let's go ahead and drop it, and it goes with this 2020 over here. And then this thing is steel, but we could always go and change it. That's not a big issue. So, let's go. Beautiful. Yep. Looks like it lines up. Perfect. So that's one. And as you can see, it's steel. It's not how it's supposed to be, and you change the material properties. Beautiful. Easy, easy. Then we need the bottom, the other two, which are 2040, 630. So this is going to be the bottom x-axis, bottom y-axis. These are 2040, 630. 2040, 630. Whoops. 630 millimeters. Okay. And there it is. And then we go in here, bodies, physical material, metal, aluminum. Aluminum. So now we go and save this one. Go save this one. Go in here, update. And there we go. So now this is our box here. These are the bottoms and these are the tops. Very nicely reinforced. And then we could look at how this bracket goes across, this support bracket. I'm wondering if 220 is high, 225 is high price. That's a good question. I'll have to think about that. So now, again, what I'm going to do here is do 25 millimeter by 12.5 millimeter. Then this goes up 870 millimeters, 870 millimeters. Then, I'm sure it has a hole in it someplace, and then this is going to be stainless. I don't know what kind of stainless, it's just stainless. Stainless steel of some type. I'm just going to call it stainless steel brace, just so we could see this in general for clearance. Interesting. So we do have some clipping here. Yeah, because I think so. These ones are actually probably the shorter ones. These are supposed to be. Because I think of both of them. So these are the Y. The Y actually has to be shorter. I think these are actually, okay, so it's supposed to be 630. What are these? Interesting. So somebody made a little bit of a goof here somewhere. Or I did, one of the two. Let's see. Okay. But then again, they did all the machining too on the rails. I think it's probably worth $225. Have all the gantries done. Don't have to do any of this stuff. We're just gonna model it so you can see kind of how everything else goes. Anyways, not exactly sure how this is going to go because we don't really have a pre-described point for it to go. So yeah, basically like that. What is that rotation? 148. Oops. So this should be 48. Yeah. There we go. So basically like that. When really I think it should be here. I mean, at the end of the day, it's probably going to be here, here, and here. I'll probably make more of these brackets. But right now, 2 is okay. And again, these motor brackets, once I get them, I'll probably instantly make them into metal, and then also make these into metal. Because I think, so the weird thing is that the pulleys and the gantries are out of metal, but those are not. Very strange. Alright, so that's basically what our housing looks like. So let's get a better look at it. And so now, what is our inside volume? Why is it sideways? Yeah, actually, let's do the inside square. $25 about 24 inches by 25 inches. So, what that means I just noticed that this has kind of a different wheel setup. Anyways, So yeah, so that's good. So that means that, let's see. So technically we could drop almost 2 inches here, almost 2 inches here, and still be okay. So let's see. Let's draw some cross braces here. What? Oh, yeah, not that one. Dimension. No. Oh, this one's short. So that one's only a little bit shorter. And then the head, because the head has some diameter, we're going to lose that. So we might need a little bit of a lopsided plate to fit in there. We're probably going to lose a good maybe 23 inches. But more like over here. See, we might have 23 by, I would say this is probably okay, 23 by 24. Yeah, so we could definitely get, obviously you saw that we get 24 by 24. We could definitely get one sheet in this. And then if we look at the outside, let's look at the outside. Oh, so the outside is actually this way. "29 inches, perfect." "29 by 20, 29 by 28." So what we could do is we could put it in there sideways. But then we're going to have the gantry sticking out. But yeah, we're going to have motors sticking out this way, so it's going to be even longer. But again, that space that's supposed to fit in is 28 inches. So 1 inch more, 1 inch and a little bit of change is fine. This is perfect for that segment. And 1 inch is really small. It's just barely going to stick out of that cabinet area by 1 inch. And maybe even we could turn it sideways and try to get that back. Same deal as this printer right here. It's sticking way far out. Well, then again, I have a big spool on it, so that's why. And then we'll have our pump and stuff over here. It's going to look pretty good. Because this way I think we have like 48 inches, which is going to fit underneath my Tormach equivalent DIY mill. Okay, so how much water can we stick in there? So it'll probably be that whole thing there. Okay, so let's see the loss here with the head. So an example. This is just an example. I'm gonna say like 4 inches. So can I do like 2 object and then some sort of offset? Yeah, negative. Let's see. I'm going to say negative 3 inches. Okay, so there is our solid. Oh, let's do this here. Offset from here. Let's make this negative 0.0.0. Let's see, 16 gauge steel thickness. 0.065. Negative. Oh. Positive 0.065. There we go. There we go. Then, oh, also not all the way down the bottom. Ooh, I think I set it to join. We don't want it to join. We want it new body. What? Oh yeah, there's only one body. Right. Cool. So then what we need to do is we need to do a sketch off of this. Project everything. Project. Now we want it to go inside. Negative 0.065. Now it should be flush here. Yep. Okay, so now then we're gonna touch this, and then we're gonna go distance to object. And then we want it to go down about, how far below waterline? Maybe an inch, maybe have it an inch below water. Okay. Water. And there we go. Again, this is going to be a bitch to clean. Basically, what I'll probably want to do is be able to take the head off and just set it aside and then work on all this stuff. But then it's really hard to make it all square again. So, anyways, water. Okay. Properties, mass. Oops. $9,652. About 600 pounds of water with a volume of, let's go ahead and look at the volume. 1673 1673 1 2 oops, so it's here 1 2 3 4 1 6, that's 1 2, 3, 4. So cubic inches to gallons. Cubic inches 16730. It's almost 70. Let's make sure that's right. 1, 2. Oh, it's only 3. Whoops. Yeah, 1, 2, 3. Why would they tell you that? Oh, E to the 4. It is, yeah. Yeah. So that's 72 and a half gallons. That's a lot of water. Now, let's say it's 50% efficient. So here's an interesting thing. Let's say it's 50% efficient. So let's see. Water, natural convection. Okay, so let's just use this calculator. I don't think it's really for water, but hey, whatever. Let's change everything to meters. So I want to see how much this... The reason why I'm looking at a lot of mass is I want it to cool down the pump and yet not be, so crazy here. Okay, so area is meters 0.405 meters cubed. Perimeter, I'll show you in a second what I'm doing here. It's 2.628. Surface temperature, let's say 23. Surrounding media, air. Calculate. Oh yeah, surface temperature 23. It can't be 23. Okay, how about this? We need a sink. So yeah, we need to know some sort of temperature here. But basically I know that that's like a 1 horsepower compressor. So let's say, I think it's a 1 horsepower or 2 horsepower or something. So let's say it's a 2 horsepower compressor. It's 60% efficient, let's say. So that is 1.2 horsepower, and then let's say to air compressing water is about 50% efficient. So altogether, let's say that we're dumping in 0.6. So that's 0.6 horsepower. So altogether, we're dumping in 1.4 horsepower, which is we can just round it up to 1.5. So 750 times 1.5 is 375 plus 750. So that's 10. I think it's like 1,035 watts. So if we go here, oops. Let's just say 1,000 watts. Oops. Okay, it's all conducting. Let's just say it's got an H of like, this has got an H of like 2, this has got an H of like 2. So load, thermal load, convection. This has got 1, this has got 1, this has got 1. This has got 1. This has got 1. Let's just say surrounding temperature, 23 degrees centigrade. Let's say 3.6. So this is the calculator I like to use. It's from QuickFields. You say horizontal plane, it doesn't really matter. Plane area, plane perimeter, surface temperature, surrounding media temperature, air. You could also do other. You get a whole bunch of stuff. And it just gives you a rough, and here you go. Here's all the stuff. Grashoff's number is the right thing to do here. And Reynolds number and then Nusselt number. And then, so there you get H from Nusselt's number. That is correct. So let's do that and let's see what happens. Let's call that it, I guess. Ooh, she getting hot. Okay, so this is what, let's do this one more time. Model view. Let's say all faces. Alright, let's do it one more time. Oops, still at 90. Interesting. I wonder why all the heat is right there. It's supposed to be inside the material. Anyways, we'll figure it out. Okay, so that's pretty much it for this video. We'll talk more about this next week. This has been Steven from Legit Tech Tutorials. Thank you guys for watching. I'll see you guys in the next one. Take it easy. Peace.